Hi everyone, and welcome to the following of Web3.js tutorials of the blockchain series of tutorials. So this part we're going to continue with our code, and we're going to deploy our compiled smart contract. So in the previous one we managed to compile our smart contract, and as you can see the result is two variables that are necessary for us to deploy the contract. The first one is ABI, the second one is bytecode. So right now what we're going to do is to write the function for the deployment. Before we do that, make sure you have Ganache installed. So right over here, as you can see, I've got Ganache on my own operating system. So you might install it on Windows. It has a different icon. So all you need to do is to click on it. So if you're on Linux, make sure you, before you open it up, by just double clicking on it. If it doesn't work, you need to go to Properties, and there's an option for the permission. You need to allow executing file as program in order for you to make it happen. But if you're on any other operating system, it will be fine, and it should work for you. Anyway, you click on Quick Start, and for this part, all you need to do is to copy this RPC server. So I'm going to tell you where we need to apply it. So, and also I'm not sure if we're gonna have the time for this part of the video or in the next one, but we're gonna need it. Oh yeah, we need it for this one because we're working with Web3, and so we need to define it. And in order to make that happen, we need a HTTP provider, which is this one. This is a simulated blockchain, so we need a kind of HTTP provider for us to connect us to the blockchain. So this is a kind of a local blockchain for us, and as you can see, it has 127.0.0.1, which is a kind of a local server for you. And then it has a port 7545 for you. The number might differ, maybe 8545, doesn't matter. So all you need to do is to copy it and paste it in your code. I'm going to tell you about the process. So the first thing you need to do is to define a function. So function, okay, so also this is going to be an async function. Okay, so async function, and by the way, let's push this here, and we shouldn't use them because the function is compiled. So we only use these three sentences when we want to compile the project. If it has been already compiled and we have the data in contract data.json, then it's compiled, and we don't need to recompile it unless the smart contract changes and we need to recompile it. So now let's name the function. It's going to be deploy. So this is the name I've preferred for it. So we're gonna get Web3, and I'm gonna tell you what Web3 is. So we got the JSON file path. So we need this path in order to import the data from the JSON file containing the bytecode and API. So, and also we need a private key, which again we're gonna get it from the Ganache. So Ganache here gives us a number of accounts, and as you can see, this is the public key. And in order to get the private key, you can click on Show Keys for each account, and as you can see, there is a specific private key for any one of them. And notice that the private key changes each time. Also, the address changes each time when you restart the Ganache. So there are a different number of addresses, and they're not constant all the time. So if you're copying and pasting in the code, and another time you're restarting Ganache, make sure that you change the address, which is the public key here, and also the private key over here each time. But in a real world kind of a blockchain, these addresses don't change. This is just a simulated blockchain, and it resets the information whenever you restart the GUI. Anyway, let's get back to our code here. So we need a number of data. These are the inputs of the function. So let's open it up, and the first thing we need here is, first of all, before we get into the function, let me define Web3. So we're using Web3, what it is and how to define it. So in order to define Web3, we need, as I told you, we need the HTTP provider data, and also it's going to use the imported library related to Web3 that we already installed. So Web3 equals new Web3. So this is with the capital letter, and this is the one that we've imported. So now we're going to open parentheses, and then instead of it we have again new Web3 dot. So make sure you have this as a new Web3 and again another new Web3 inside of it. It might not make any sense for you for now, but this is the way the library is written. So in some newer versions it might be different, so make sure about the version management. So the version of Web3 we're using, just as I told you earlier, can be read from this package.json. For us this is 1.5.2. There are newer versions available, so if you're following along with this tutorial you need to make sure you're installing this version of Web3. Anyway, so new Web3 dot providers dot HTTP provider and here is where we enter the endpoint for a blockchain. Sometimes it's testnet, so we need to get it from some kind of a endpoint from Infura or other places such as Alchemy, but here we're using the simulated blockchain, so all we need to do is to copy and paste it from Ganache GUI. So I'm gonna get it from here, Ganache GUI, and copy the RPC server. So what I need to do is to paste it over here, and this is the semicolon at the end. So that's it. We've defined Web3. So whenever we want to call this function, we will need to have this variable, which is Web3. So we've got it. Also, we've got JSON file path, which I have it over here. So no need to comment out this part. I'm gonna copy it above here, and so we need it for most of the parts, most of the functions. We need this JSON file path because we need ABI, and we also need the bytecode. So that's why we need to import this file path in any one of them and try to get the file and read the data from it. So that's why the first thing we do inside of a function is to try to read from the file. So const, so that we've got the file path, right? So we don't need to do anything in terms of getting the data. So we have const file data equals fs dot read file sync, read file sync, and it will get the JSON file path and it should be in the format of UTF-8. Here we go, and the next line will have const compiled data, const compiled data, which equals the JSON.parse, JSON.parse, and it will get the file data. So here we read from the JSON file, and now we're parsing the JSON file and getting the data, which contains the ABI and bytecode, which is like this. So it is in stringified, so we need to do something reverse to stringifying. So this is JSON.parse, and so we've got the data. Now what we're gonna do is we need to extract the ABI from it and also the bytecode. So we'll get compiled data, and from that we'll get the ABI and also the bytecode. So bytecode here equals the same thing. So we have compiled data. So So actually this is compiled. Okay, this is compiled data. So here we go. So bytecode. So we need the stringified. Also, actually this should be a string because we're getting the bytecode. So we need to make sure it's a string. So we write string function and then compiled data. And then we have a square bracket and we're going to get the bytecode from it. Bytecode like this. This is the way it's written inside of our JSON file. Let's double check here. So our bytecode, yes, it's with capital letters at the beginning, not exactly camel case. Doesn't matter. So here we go. We have the ABI and the bytecode. And now we need to also catch the error in case we've got any errors. So we catch the error and open the brackets, and here console.log the error. Console.log, so failed to read ABI from file, failed to read ABI from file. So also we'll write the error instead of it. So that's it for this part. And then after getting the data, ABI and bytecode from the file, we will have the contract, and we'll get the contract and the account. So in order to get the contract, we need again the Web3 library. So const contract equals new web3.eth, new web3.eth dot accounts dot private key to so that's contract, actually that's contract. So these are the attributes, these are the properties of web3. So web3.eth dot accounts dot contract. So actually do not need this account. Account is for when we want to get the private key and other stuff. So here we have the eth.contract. So here from the ABI we'll get the contract in one variable. This is the function that Web3.js converts the ABI to the contract variable. And as you can see here, this is the ABI, right? This is an object containing all of different properties of the contract. So it will then convert it into a variable called contract. Now the first step is to write const account. Const account equals web3 that eth dot accounts dot private key. So from the private key we'll get the account, and that is the main part because we're going to deploy the contract from one account, and in order to have the permission of that account we need the private key. So if you only want to do this with the public key, this is not going to happen because anyone has access to the public key of that specific account. So but the private key, which is unique for every person, and only that person has permission and has access to that private key. So it makes that person to be able to deploy that contract. So that's why we need to enter the private key. And also we get the private key from the function. So we have imported instead of a function from here. So this is the private key that we'll get, and this is the account that is going to deploy the contract and initialize it. So the next thing we're going to do is to add this account to the valid. So we've got a function here in web3, web3.eth dot accounts dot valid. So we can have a valid and a number of accounts. So I will show you how that happens. So as you can see, we've added an account to our valid, right, in Web3. And you might wonder what is the difference between a valid and an account. Valid can contain a number of accounts, just like here we have one valid and a number of accounts. However, here this is a simulated blockchain, and not necessarily all of these are inside one valid, this is just a simulate blockchain. But sometimes whenever we go forward and we're working with MetaMask, you will see that we have one MetaMask wallet with a number of accounts inside of them, and each account has its address, but all of the accounts altogether has the same mnemonic key. As you can see, this is the same. So there's one mnemonic key, but there are a lot of account addresses and their own private keys. So this is a very important thing to consider. Here we have the same thing. So we have the wallet here, and we've added the account to the wallet. So anyway, let's continue here. So we have also web3.eth.default account, web3.eth.default account, and this equals the account.address. So the default account should be the account.address. So the address that we'll have, this is not necessarily all the times, but sometimes this sentence is necessary. So the default account should be the account that we've got here from the private key, and by just running account.address you will get the public key. So you have the private key, and once you have the private key you can also get the public key. But the reverse process, when you have the public key, you can't get the private key, because you might be somebody else who does not have the permission to use that account, but you have the account address, so you're not able to get the private key from it, right? But once you have the private key, you can easily get the account address or public key. So these are the protocols in the accounts of blockchain. You need to also consider that these exist. So we also need a number of other variables for deploying the contract. But that's it for this particular tutorial. We're going to continue with the rest of the process in the deploy function in the next video. So until the next one, goodbye.